Hello everyone. Today I want to talk about an exciting feature in Python that can help us to improve the performance of our functions through a technique called memoization. Specifically, we will explore how the LRU cache decorator from functools module can speed up our computation. Let's start with the problem we are talking: calculating factorial of a number. The factorial function multiplies a number by every positive integer less than it until it reaches to 1. For instance, the factorial of 5 is 5 times, 4 times, 3 times, 2 times 1, which is equal to 120. Now I have implemented two versions of the factorial function. The first version, named factorial, is straightforward recursive function that compute the factorial without any caching. Here is how it works. The function calls itself repeatedly, leading to a significant number of calculations, especially for large numbers. To illustrate this, I use the time module to measure the execution time when calculating factorial of 300. As expected, it took a noticeable amount of time to compute. Now let's move on the second version of our factorial function, which uses the LRU decorator. By decorating the function with LRU cache, we enable caching of the result previously computed inputs. This means if the function is called again with the same argument, it can return the cache result instead of recalculating it. This is particularly useful for recursive function where the same value can be computed multiple times. To demonstrate the difference in execution time, I again time the factorial computation of 300 using the cache version. This result was remarkable. While the first version took a measurable amount of time, the cache version executed almost instantly, saving us a lot of computational resources. Finally, I included a comparison of using the timeit magic command in the Jupyter Notebook. This command allows us to measure the execution time of small code snippets effectively. When comparing the factorial 10 and the factorial with cache 10, we can see that the cache version dramatically faster and compared to the non-cache version. In conclusion, the use of LRU cache for memoization demonstrates the power of caching in Python. It helps us optimize our functions, reducing the time complexity significantly for repeated computation. This is a great example of how simple changes can lead to the substantial improvement of the performance. Thank you for your attention, and I hope you find its features will be useful for your code, and I have used it in my coding endeavors. Thank you all.